Okay, welcome to week 2, part 1. We're going to do an introduction to exploratory data analysis. Data, as we all know, are everywhere. And in particular, your data is everywhere. Any number of internet companies, banks, retailers, on and on and on, have your data and are busily selling it to other people. We also have geographic kind of data that we need to worry about, manufacturing process data that you might need to worry about, health data, on and on and on. Okay, this slide actually is interesting. It's actually 6 years old, and yet even 6 years ago, Twitter was doing 500 million tweets per day. Almost 300 billion email messages were being sent every day by almost 4 billion people, and we can assume that both of those numbers are significantly higher now. 463 exabytes of data are created every day, according to this, by 2025. So there we are. Now, an exabyte, in case you're not aware, let me see if I can home in on that table. Okay, there we go. Okay, so we've got kilobytes, megabytes, gigabytes, terabytes, petabytes, I think this is exabytes. I can't read it. So, a billion bytes of data every day, or maybe a trillion billion bytes of data every day. In any case, now, so when you're doing exploratory data analysis, in all likelihood, it's not going to be on data that you have collected yourself or that you are particularly familiar with. So one of the first things to concern yourself about is where did the data come from? Who collected and processed the data? What was their intent? Do you think they have baked into the data that they collected a bias toward a certain preconceived notion that they have, or do you think that the data are representative of true reality? Did you get the data from a reputable source? All of this is something to be concerned about, but I will tell you from long sad experience that even if you do get your data from a completely reputable source, and you know who it was that gathered that data, you'll be stunned frequently at how poor the whole data collection process is. And how much mess there is in the data that you're trying to analyze. Okay, so the data that you get are going to be an absolute mess almost always. Data wrangling is the next step in dealing with this data set that you've been given. As a first pass, you do want to look at the data, figure out how big the data is, figure out what attributes there are for the data, how many observations you have in the data, maybe some really simple statistics like some means and standard deviations of numerical data, some frequency counts of categorical data like true-false values in various columns, things of that kind. And that process will cause you to discover that the data are a mess. You probably have missing values. You probably have duplicate ID numbers for various things in the data. You probably have inconsistencies in how the data were recorded. You may find that part of the data that you got has a field in which the person creating the data can put commentary. And in that case, you'll find that almost everything interesting about that particular record of data is contained in the commentary rather than in the particular labeled fields, and you'll have to figure out how to extract that meaningful data from that unstructured commentary. Okay, so this data wrangling is itself a kind of painful iterative process. You will do some cleaning. You'll discover that you have more cleaning to do. You'll do some more cleaning, and this will go round and around and around. I was involved in a project, I don't know, about a decade ago, I suppose, where we had maintenance data for a particular type of aircraft in the Air Force, and we were supposed to extract meaningful information about the kind and frequency of maintenance that needed to be done on these aircrafts. And one of the first fields in the data was a unique identifier that uniquely identified a particular maintenance operation. And after we'd been working with the data for about 6 months, we learned that these unique identifiers were not unique after all. So you could have multiple maintenance operations occurring on different aircraft in different locations that were all identified as the same maintenance operation. So this whole process of data wrangling and data cleaning can be extraordinarily time-consuming and painful, and you keep learning more and more and more as you progress. Okay, now in terms of different kinds of data that we have to work with, you have probably done statistical training in the past, and most of that kind of introductory statistical training involves analyzing numerical data, things like stock prices or temperature fluctuations over time, the top speed of various cars, how much those cars weigh, who manufactured them, how long it takes them to accelerate to 60 miles an hour, what is the incidence of violent crimes in various locations around various cities, how many illnesses of a certain type have been detected in various locations, on and on. Numerical data. With numerical data, you can do simple things like computing means, computing standard deviations, computing trends. Trends, assuming that this information is over time. You can compute distributions and put together confidence intervals and all this kind of good stuff. But you also are often faced with categorical data, which, you can't define means and standard deviations of categorical data. Categorical data is either one kind of thing or another kind of thing or another kind of thing. For example, the breed of a dog is categorical information. We can't talk about the average breed of a dog or the standard deviation of the breed of the dog. In those kinds of cases, we can do things like creating histograms, like how popular are various different breeds of dogs, things of that kind. So we've got numerical data, categorical data. We also have textual data, which may contain a whole mixture of different kinds of other data, and we can scan the text data for patterns. We can perhaps extract meaningful subportions of text to give us additional categorical information or additional numerical information. There are time series data in which we can look at changes over time of some thing of concern. Like here we're looking at the deaths from COVID in the United States on a, I guess this is on a daily basis, starting in about the middle of March through the end of October of 2020. And of course the deaths from COVID continued on after that, but this is just showing that particular time period. And here we can worry about things like serial correlations and trends and things of that sort. We have geographical data, keeping track of where certain kinds of events occurred and how frequent they were in certain areas and so on. So lots of different kinds of data that we're going to take a look at how to deal with. Okay, so can we define what in the world we mean by exploratory data analysis and visualization? Well, exploratory data analysis, I guess, is sort of self-defining. You get handed some data, and you need to, first of all, figure out what the data means, figure out what your client, your boss, the funding agency, the company that you are creating information for, if it's an outside company that has hired you to do some consulting or something of this kind, you need to figure out what the goal of the analysis is supposed to be, and then see whether you can make sense of the data that you've been given to determine, first of all, whether the data that you've been given is sufficient to be able to answer the question that you've been asked, to find out if you can obtain more data, if the data that you have is not sufficient, which I hate to say it, but it probably won't be sufficient. You need to figure out the meanings of all the various different columns in the data that you've been given. You need to figure out whether there are other columns or so-called features that can be constructed from the columns that you have, and sometimes extracted out of unstructured text in the columns that you have. And once you have finally got the data cleaned up to a point where it can be analyzed, then you perform whatever kind of statistical analysis makes sense. Figure out what the mean is, figure out what the standard deviation is, figure out what the skew is, figure out what the distribution looks like, identify outliers and decide what to do about outliers, and all this kind of thing. And then visualization is the effort to take what you have learned about the data, aimed at the kind of decision that the client, the ultimate consumer of your analysis, wants, and put the data not into just tables of numbers, but meaningful plots that can convey both high and low level meaning to the consumers of the charts. Now, okay, so EDA is an iterative process. You're not going to figure it all out the first time you look at a data set. You will look at a data set, you will try to understand the data set, you will develop questions about certain things in the data set, and then hopefully you can get answers to these questions by querying experts who provided you with the data, and or by just working things out for yourself. And you always need to maintain a healthy skepticism about whether you are really understanding your data or not. Okay, so after you have examined the data and come up with some questions to ask about it and tried to get answers to these questions, then you look at the data again more deeply and see whether that raises even more questions. And this just loops and loops and loops around. All right, now various people have put together varying degrees of formalizations of exploratory data analysis. Here is a chart from an outfit called thingsolver.com, from a talk called EDA Done Right, and I certainly encourage you to read what they have done. Their description of exploratory data analysis is much broader than what we're going to be concerned about here, because in their definition of exploratory data analysis, they start out with the process of defining a particular business problem that their client has, and then discussing with the client what data might be available to help them get an analysis done that will help them solve their business problem. All right, so here we are interacting with the client even before organized data exists to help them nail down exactly what question they need an answer to, and nail down what kind of data they have that might be available in order to help with this analysis. Okay, then once we have a general idea of what data might be available, we're going to identify the specific data sources within the company, which might include information found in databases, information found in various employees and departments' spreadsheets, et cetera, gather all of this stuff together, and then sort of organize a plan of attack about setting up the exploratory data analysis of this. Now, I am I have to laugh at these arrows that are all flowing from left to right. This is very optimistic. That you're going to do you're going to define the problem, get the data, set up the exploratory data analysis, do the exploratory data analysis, and present the insights. In fact, these middle three here, at the very least, I mean, I guess we can have a starting state and we can have a stopping state. That makes sense. But these middle three here, this is going to be not a straight line. This is going to be a loop. that's going to go on and on and on and on until you have all come into agreement about what the problem is, what the data are, what the data actually means, whether you have all the data that you need, and then finally get to some kind of solution. So this is consulting stuff that looks really easy and isn't. I mean, they do kind of break down what the individual steps are, but the steps are cycles. They're not linear there. Here's maybe a better diagram without getting into great depth here. That this is all a cyclical process. Here's a more informal look at the same idea. And actually, this informal look is not that dissimilar from this very formalized, very linear approach shown a couple slides back. But, there's an emphasis here on the iterative nature of things. You have an idea of what you're trying to accomplish. You go out and collect data. Now, maybe as an exploratory data analyst, maybe somebody just hands you some data. More likely, though, you're going to have to coordinate with the client to obtain data. They may provide you with some initial data, but you may discover that the initial data they provided you with is insufficient, and so you'll have to very likely interact with them in a cyclical fashion to actually get more data. At the same time that I was working on this project with aircraft maintenance, one of the other people in our lab was working with a manufacturer of large, heavy machinery, like earth movers and bulldozers and things of this kind. And my friend was tasked to perform a statistical analysis on the engine, the behavior of engines in a particular kind of bulldozer. And the client had one data point. Now, you can imagine how much interesting statistics you can do with a single data point. So a very great deal of her job ended up being helping them get a lot more data so that they can actually do something meaningful. Okay, so once you have collected data, and this is going to be an ongoing process. Here they're saying add more data every so often. We're going to load the data into our exploratory data analysis process. We're going to check the types of the various columns in our data. We're going to check the distributions of all those columns to see whether we notice any skewed or ridiculous distributions, whether we discover outliers that don't make any sense. If we, for example, were looking at a data set involving pet dogs, and we found a dog whose weight was listed as 1,500 pounds, well, that's an outlier, and you got to figure out how to fix that. First of all, you have to have a method, a way of deciding when you're looking at an outlier, and then you have to decide what you're going to do to fix that. This whole process of looking at the attributes that you have, the data attributes that you have, which we think of as being like the columns in our data set, the columns in our data frame in Python, we may discover that we need to create additional columns, additional attributes, based on the attributes that we do have. This is called feature engineering, creating new composite data. And then we run our evaluation models on that revised data and add some more data and circle around and around. Okay. So I guess part of the whole point of all this talk is to scare you and make you a little bit cynical about how easy or difficult this whole thing is. All right, now once we have actually accomplished some analysis, and in fact even during the process of doing our analysis, we're going to want to produce visualizations that help us see the big picture and interpret our results. Okay? And this is both a science and an art in getting good visualizations created. There are all kinds of canned, all kinds of canned visualizations that we can create, like box plots, heat maps, histograms, bar charts, etc. And people often, when they're creating visualizations of data that they've analyzed, they just have kind of their favorite set of plots that they just trot out and hope that these plots are meaningful to whoever it is that's reading their analysis. But there's actually a great deal of skill involved in really focusing on plots that are well designed, not too cluttered up, definitely not misleading. If you create a misleading plot, that's better than creating no plot. That's worse than creating no plot at all. And of course, nowadays we also have tools available that are even more powerful than what Python can do for creating even more imaginative and meaningful kinds of plots. It is worthwhile to go on YouTube and just do a search for EDA and visualization, exploratory data analysis and visualization, and see what you can pull up as far as TED Talks and business presentations, and so on, to see what kinds of ideas people have about doing this visualization part. Okay. So here again, this is just kind of describing the cyclical nature of this whole process. We explore the data. We discover some interesting relations among the data. Display a plot that shows us what's going on, and then the whole thing loops around again. Okay. All right. So data visualization not only helps convey meaning to our eventual client, but data visualization can also help us, the analyst, notice more clearly things that are missing, things that are obvious outliers, things that just don't make sense. The visualizations can help us go back and continue cleaning and continue analyzing the data that we have. Ultimately, we would like to be able to create stories that cause the major discoveries that we've made to really hit home and sink in with our clients. All right. Well, here's, this is just yet another model of the whole cyclical nature of all of this process. And here's some example plots. These are many of the most popular coffee vendors in the country. So Starbucks is kind of the most widespread. It's all over the country. Seattle's Best is also all over the country, but not nearly as popular as Starbucks. In the Northwest, there's apparently an outfit called Dutch Brothers, which I personally have no familiarity with. And then on the West Coast, there's Pete's and the Coffee Bean. Now, Tim Hortons is a very popular chain of coffee and pastry shops, breakfast shops in Canada that has begun making inroads in the northern United States, particularly up in the New York, New England area. Caribou Coffee is sort of the coffee vendor in my home state of Minnesota. So I thought everybody drank Caribou Coffee, but apparently nobody drinks Caribou Coffee except for people in Minnesota. In the East and Chicago, Dunkin' Donuts has been around forever and is still the leading vendor of coffee. So these graphs, they're not, they don't have precision. They don't have lots of tables of numbers with names of cities and so on and so forth. But they do convey very important meaning to somebody who's trying to understand, what coffee vendors are popular in various parts of the country. Here's an alternate way of looking at that same information. This graphic shows all of the different coffee vendors on the same map with the various dots indicating the density of that particular coffee vendor. Okay, so here we've got Starbucks all over the place, but Dunkin' Donuts, very important, especially in the Northeast, but also along the West Coast and out into the Chicago area. And Caribou, okay, these pale blue dots up here, mostly Minnesota, a little bit Wisconsin, Iowa, South Dakota. Not very, again, this is not very quantitative, but it is a very helpful visualization. Okay, so visualization is usually done for the purpose of communicating an important idea. Like kind of the main thing to know from having done with the data set. Okay. Here is a vertical list, basically of the same kind of ideas that were shown on this horizontal list of steps involved in the EDA and visualization process. we need to start out by understanding what the problem is that our client wants us to solve, and then design a solution which involves obtaining data that will enable us to solve the problem. What data is available? How can we get this data? How can we get even more data? What data needs to be collected in addition to what already exists? How do we clean and organize and structure the data to make it analyzable? And then also, how do we validate that our solution makes sense? And how do we evaluate the meaning of our solution? There is both creativity and experience necessary for this entire process, and patience and what's the term I'm after? Relentlessness. You just have to keep pounding and pounding and pounding at the data, checking out your analyses to make sure that you really actually do understand the data that you've been given. And as I have found more than once, very often the people who provide you with the data are wrong about the meaning of the data that they have given you. So it becomes a kind of mutual education process. All right. All right. So in this course, we're going to take a look at statistical concepts that allow us to analyze the data. We're going to take a look at Python facilities that allow us to do this exploratory data analysis. We're also going to take a look at Python libraries that allow us to do data visualization. And we're going to try to figure out which data visualizations are effective and which are not. All right. All right, and so here we get to our conclusion, which repeats things that I've said. Data is a mess. And the vast majority of your time, if you're doing data analysis in the real world, is going to be involved with just figuring out what the data means and cleaning up the data and obtaining more data to fill in the gaps for, in order to be able to complete the analysis that you've been asked to complete. Python is going to be a very important tool for us. It does a lot for us, but it's probably not the only tool that you should use. You may find yourself using SQL database systems or Excel or ordinary text editors or various other tools to help muck around with the data that you're eventually going to ask Python to analyze. Okay, so there's my sales pitch.